Hello and welcome back to AmpCode. This will be the last lecture of our Apache PySpark tutorial for beginners. So this lecture is all about model management as well as the deployment options that are available in the MLlib library. So without wasting any time, let's get into it. So this lecture is all about how to manage, deploy and scale our machine learning pipeline using Apache Spark. So in the previous lectures, we have covered how to build machine learning pipeline with MLlib library. But this lecture will focus on how to manage and deploy the models you have trained in the previous lecture. So by the end of this lecture, you will able to use MLflow for tracking, reproducing and deploy your MLlib models. So let's first discuss about some of the best practices for model management to get your model ready for deployment. So before you deploy your machine learning model, you should ensure that you can reproduce and track the model's performance. So for us, like end-to-end reproducibility by machine learning solution means that we need to able to reproduce the code that generated our model, as well as the environment which is used in the training and the data that our machine learning model was trained on, and also the model itself. So every data scientist will remind you for setting your seeds so you can reproduce your experiments. So for example, for training or testing split when using the models with inherent randomness such as random forest. But however, there are many more aspects that will contribute for reproducibility than just setting the seeds. And some of them are much more subtle. Let's discuss them one by one. The first one will be the library versioning. So when a data scientist hand you on their code, they may or may not mention the dependent libraries. So while you are able to figure out which libraries are required by going through the error message, you won't be certain which library versions they have used, so that you will likely install the latest one. So here directly pip install all the packages while going through the error will not help, because you don't know which version they have used. So that if their codes are built on a previous version of the library, they may take advantage of some default behavior which will differ from the version you have installed. So using the latest version can cause the code to break and error out, and this may cause an issue. And also there might be some changes in your results. So library versioning is very important while building machine learning model. Next one is the data evolution. So let's suppose you build a model on June 1, 2023 and keep track of all your hyperparameters as well as the libraries which we discussed in the previous topic, but you then try to reproduce the same model on the next month, but the pipeline will break or result some differences because the underlying data has changed. So which could happen if someone added an extra column or added some more data after the initial build. So that could cause an issue. So you have to make sure of the data evolution as well. The next one is the order of execution. So if a data scientist will hand you their code, you should be able to run it top to bottom without any error. But however, data scientists are notorious for running things out of the order. So it is not like they have given you the Jupyter notebook and you just have to go step by step. There might be some cases where the order is not defined. And also they might check in a copy of code with different hyperparameters than those used to train the final model. So that can also cause an issue. The next one is a parallel operation. So to maximize the throughput value, our GPUs will run many operations in parallel. But however, the order of execution is not always guaranteed, so which can lead us to a non-deterministic output. This is a very known problem with functions like the reduce sum. And when aggregating a floating point number, the order in which you added them may generate some differences in the final results, and which can cause the exaggerated across many iteration. So these are some of the things you need to make sure while managing your model. So the inability for reproducing your experiment can often be a blocker in getting business units to adopt your model or put it into the production. So that can cause your deployment. But while you could build your own in-house tools for tracking your models as well as the data as well as the version that we talk about, they may become obsolete as well as brittle and may take significant development effort for maintaining this process. And it is important to have industry-wide standards for managing the models so that they can be easily shared with the partners. So if anyone hands over their code to you, you may not face any of the issues we have discussed in this topic. And also there are both open source and the proprietary tools that will help you reproducing your machine learning experiments, and it does that using the extracting away many of those common difficulties. So in the next section we are going to focus on the MLflow. So MLflow is a tightest integration with MLlib, and it is currently available open source, and it is a model management tool. So let's talk about it in detail. MLflow is nothing but an open source platform which helps developer to reproduce and share the experiments as well as managing the models and many more things. So it will provide the interface in Python as well as Java, Scala as well as the REST API. So it is a very versatile tool across developers. So as shown in this figure, MLflow has major 4 components. The first one is the tracking. So it provides the APIs for recording the parameters as well as the metrics as well as different things like code versioning, the models, artifacts, etc. So this is very convenient for tracking your machine learning model. The next one is the project. So a standardized format to package your data science project and their dependencies for running it on the other platforms. That is very important, and it will help you manage the model training process. Then comes the models. So a standardized format for packaging the models and also deploy to a diverse execution environments. This is also a very important thing for deploying your model to the diverse environment. And it will provide you the consistent API for loading and applying the model, regardless of the algorithm or whatever library you have used to build your machine learning model. And also there is a registry, which is the last component. So it is nothing but a repository for keeping track of lineage of your model, the version of your model, as well as the transition and annotation. So it is like a GitHub or Bitbucket for your machine learning model. So let's discuss more about these types in detail. So the first one is the tracking. So tracking is a logging API which organizes around the concept of runs, which are nothing but the execution of data science code. So runs are nothing but aggregated into experiments such that many runs can be part of a given experiment. So MLflow tracking server can host many experiments. So you can log in to the tracking server using notebook as well as the local app or the cloud job. So this was all about the components for MLflow. So now we are going to discuss about the model deployment options for your MLlib model. So deploying your machine learning model means that something different for every organization as well as the use case. So business constraint will impose different requirements, and it could do that for latency as well as the throughput and cost, etc. So which will dictate which mode of model deployment is suitable for the given task at your hand. So it could be a batch job as well as the streaming or the real time or the embedded job. So deploying models on an embedded system is outside of the scope of our Spark course. We will be discussing and focus on primarily on the 3 options which are available. So this first table that I have given here will show you the throughput and the latency trade-offs of these 3 deployment options, which are nothing but batch, streaming as well as the real time. So we care about both the number of concurrent requests and the size of those requests, and the resulting solution will look very different. As given here, batch processing will generate predictions on a regular schedule and writes the result out to persistent storage to be served elsewhere. So it is typically the cheapest and the easiest deployment option, as you only need to pay for the compute during your scheduled run. So batch processing is much more efficient per data point because you will accumulate less overhead when amortized across all prediction made. So this is a particular case with Spark because of the overhead of communicating back and forth between driver as well as the executor, as we have seen in the architecture of Apache Spark. So you don't want to make predictions one data point at a time. But however, its main drawback is nothing but a latency, as given in this table here. So because it is typically scheduled with a period of hours or days to generate the next batch of prediction. So on the other hand, streaming will provide a nice trade-off between throughput and the latency. So you will continuously make predictions on micro batches of data, and you will get your predictions in seconds to minutes. That is very efficient than the batch processing. So if you are using structured streaming, almost all your code will look identical to the batch use case. So it will make it easy to go back and forth between these two options. It totally depends on your requirement. So according to the requirement, your development process will not be that much of a hassle. So with streaming, you will have to pay for the virtual machines or computing resources that you will use to continually stay up and running. And it also ensures that you have configured the stream properly to be fault tolerant, and it will provide the buffering if there are any spikes in the incoming data. So this is very also important point. And on the other hand, when we talk about the real time deployment will prioritize latency over the throughput, and it will generate predictions in few milliseconds. So it is the fastest among all these types. So your infrastructure will need to support load balancing and be able to scale to many concurrent requests if there is a large spike in the demand. So example, for online retailers around the holidays, they will see a spike of load in their data. So it should accommodate this spike when they are implementing real-time approach. But sometimes people say that real-time deployment means extracting the pre-computed predictions in real time. But here we are referring to generating model prediction in real time. So real-time deployment is the only option that Spark cannot meet the latency requirement. Because as we have seen in the Spark streaming lectures, Spark is a micro batch processing tool and it doesn't actually processes the data in real time. So that is one disadvantage here. So to use it, you will need to export your model outside the Spark. So for example, if you intend to use a REST endpoint for real-time model inference, MLlib does not meet the latency requirement which are necessary for your application. So you will need to get your feature preparation and model outside the Spark, which can be like time consuming and very difficult to implement. Okay, so I hope you understood how we are approaching the model deployment options with MLlib and what are the pros and cons of all these approaches, which we have discussed through some simple example. So this was all about today's lecture. Here we have seen all about how to manage the model, how to deploy it, as well as scale the machine learning pipelines and also the different deployment types which are present in MLlib. So I hope you enjoyed this lecture. So if you face any difficulties, you can let me know in the comments and I'll get back to you as soon as possible. I hope you like this lecture, so please subscribe to our channel and also ring the notification bell to get the latest updates. And also don't forget to follow us on our social media, which I have linked in the description below. Thanks for watching.